Okay, so now we're going to talk about measuring volume and connect it to the idea of density. Now, to measure volume, it could be either you're measuring a volume of a solid or you're measuring the volume of a liquid or gas, basically. So, for now, we're going to talk about measuring the volume of a solid, and then we're going to move to a liquid. So, if you got a regular solid, you can measure its volume using any of these equations. So in O level, we're going to be asked for the cuboid, cube, and the cylinder. So you basically measure the dimensions and then you use the mathematical formula for such solids or shapes, okay? Which is basically math, right? And then the other ones, pyramid, cone, and sphere. Spheres also could be there, but the pyramid and the cone is not really in the O level, okay? And then if you want to talk about the volume of a liquid, you use a measuring cylinder. Now, when you're measuring the volume using the measuring cylinder, there's a way to read it, as we agreed. You always look at 90 degrees to avoid what? To avoid the parallax error. That's the case with any measurements that you're doing using a ruler, a measuring cylinder, or any tool. You always want to look at 90 degrees to avoid parallax error. Also, when you're looking into a liquid, you have to take the readings at the bottom of the meniscus. So that's the position of your eye. It should be at the bottom of the meniscus when you are using water. Okay. Also, the preferred measuring cylinder you should use, it should be always tall and narrow to increase the accuracy. Tall and narrow's got more divisions, so it's more accurate for you to read. Okay. Now we're gonna talk about density. Density combines the mass and volume. So density is how much or the amount of matter concentrated in a solid or liquid and a gas in a certain space. In a certain what? In a certain space. So it's defined as mass per unit volume. Okay. In density, you have a special case of units. You could use the gram combined with the centimeter cube or the kilogram with the meter cube. So you need to know how to convert, of course, the kilogram to gram and so on. So let's look at a quick example. So if you have a density of an object as 9 grams per centimeter cube, so he's asking you to find the mass of a 5 centimeter cube. So simply write mass is equal to volume times density, which is 5 times 9, you get 45 grams. In this example, you have a volume, you want to calculate the volume of 63 grams. So the volume is equal to mass over density. So that is 63 divided by 9 centimeter cube. That's going to give you 7 centimeter cube. Okay. Now watch out when you're memorizing this. So density is equal to mass over volume. Notice that when you're going to get the volume, it's the mass always again on the top, and then there is the density. If you want to get the mass, then it's density times volume. This is an easy way of remembering that. Okay. If you're going to talk about density in general, there's a thing that you need to know. It is constant for the same material, is always the same. So for example, if you have an object like this, okay, with a mass of, let's say, 10 grams, okay, and let's say the volume was 30, okay, so 30 centimeters cube. So density for this object is 10 divided by 30, so that is 1 over 3 gram per centimeter cube. You don't write fractions, you always write it as decimal points, but for now let's say it's 1 over 3. So if you're gonna increase this object again, so let's say I have the same object, you're gonna increase the material. So if let's say it increases again, so now it increased by 10 grams, and also the volume increased by what? By 30 centimeter cube. So now what's the total? The total is 20 divided by 60. You're always gonna get again is 1 over 3 gram per centimeter cube, which is why we say the density is constant for the same material. As you can say, if mass is increased and volume is kept the same, then the density will definitely change. But as we said at the start, if you've increased the volume, subsequently the mass will increase, and therefore the density will stay the same. Okay, That's for the idea of why density is constant for the same material. Now, the idea of floating and sinking, if we say the less dense floats on the more dense, so that's something to remember. The less dense floats on the more dense. Keep that in mind always when it comes to liquids or gases. It's always the same idea. Even with gases and solids, it's the same. So let's look at this example from. So you have, for example, the wood is floating at this point because it's what is less dense than water. But if we are to increase the material itself, change it to aluminum, aluminum is sinking. So therefore, aluminum is more dense than water, so the molecules are not able to lift it, okay? So that's how you see it. Now, if you look at styrofoam, for example, so it's less dense, so it floats more on the liquid or whatever the material is there, okay? That's the idea for density.